Non-uniform acceleration. The equations of motion only apply when acceleration is constant. In real-life situations this is rarely the case, and we need to analyze graphs of motion. For example, a cyclist coming down one hill then going up another might have a displacement time graph something like this. As the rate of displacement increases as they go down the hill, reaching a maximum here, and then gradually they're slowing down and the rate of increase of displacement reduces to 0 as they come to a stop. We could draw a tangent to the line at various places and find the gradient, something like this. In reality we'd plot bigger triangles than these to get more accurate data. This would allow us to plot a velocity time graph, as velocity is the gradient of a displacement time graph. That would be something like this, with the velocity increasing to a maximum, then reducing back to 0. We could repeat the process and find the gradient of the velocity time graph at several points. That would enable us to draw an acceleration time graph, which would be something like this. The acceleration increases to a maximum, then reduces to 0 acceleration, before becoming negative acceleration and then back to 0. This being the maximum acceleration, this being 0 acceleration, we then reach negative acceleration before coming back to 0. We can also work the process the other way around. By finding the area under an acceleration time graph at several points, we could plot a velocity time graph. For example, we could find the area here and so on, and from that data plot the velocity time graph. We could then find the area under the velocity time graph at various points, and from that data plot a displacement time graph.